Tutorial session is going to work like this. I'm going to select 1 or 2, 3 questions, and everybody is going to start solving. I may check a few of them. We can have some discussion, have a little bit active, and then I will show you the result or solve it for you. It will be like that. So the starting question is going to be question 4. Let's check that question. So this question says we have a tank contains 500 kilograms of liquid, something, with specific gravity is 2. Now we know what type of liquid is this. Determine the volume of the liquid in the tank. Good question. So what you need to do, you need to know what is the specific gravity and what formula we have for the volume. So pretty easy. Any data missing here? So it would be good idea to write specific gravity equation and an equation for the volume. Then combine those. Specific gravity was density of something over the density of the water at 4 degrees. And the only formula we have for the volume, it will be density formula. Now you have density for both sides of the equation combined. I should be close to my tablet to record voice. Gone? What's the final line?
You said gone. I'm not.
Hey, it's okay. Just teasing people to check if they're yeah, and I know it's a bit difficult to ask questions or involve in the class. Actually, when I was doing my bachelor, one of the biggest problems I had talking in the class, and I remember once or twice, like a lecturer told us, if anybody answered this question correctly, I'm going to give you like a 50% of the final exam. And I knew the answer. I never just scared to start talking. I don't know why. Somehow I had a problem. But later I found out if you stay active, push you to stay active and involved, automatically the sensors, they're much stronger. Just try. Of course, if like me, you're like me, it gives you anxiety. But it is a good, and nowadays in our century and in our life, the extrovert people, they are awarded. So try to practice. Introverts like me, not that much. Okay, this is rho divided by rho for the water. Rho for H2. And then what's the formula for density? Density equals M get rid of this. The only unknown is what? Small n? Oh, this is small n? No. Yeah, because the capital N has to be
I use the 0.5,000.
Density of the water is 1,000.
Okay.
Good?
Yeah.
Oh, good. Okay, let me write down. This is question 4. So basically, we need to know two formulas. One for density, which is mass divided by volume. So mass is going to be density times volume. And we know that specific gravity is density divided density of H2O at 4 degrees. So we can replace that. So I should have select other color. So I can replace this row with that row. So it is going to be Sg times density of the water times volume. So let me check what is the values. Sg was, oh, it asks for volume, so correct? Let me check what is the question. Determine volume. Okay, so the other way. So volume is going to be mass divided by Sg rho for H2O, which is comes from this. So mass is 5 kilograms, Sg is 2, and usually we consider 1000, but 999 is also correct, so it doesn't matter. Kilogram, which is going to be 0.25 meter cube. And one more point, whenever I give you a question for the quiz or final exam, I always, if I want to mark this, I give you 2 points to write this equation, and 2 points for the final exam, 1 point for the unit. So sometimes students say, oh, I'm going to get 80 out of 100 for the quiz, and then you say, oh, he hardly got 40 because losing a lot of units or just neglecting formulas. This is like a two-sided blade. For the students who made a mistake in calculation, just writing the equation, you get like a 30-40% of the question, which is really good. But you should be careful about all the details. So I care about the formula, final answer, and units. Okay, let's go for question 5. Density of a certain type of jet fuel is that number, 775 kilogram per meter cube. Determine the specific gravity and specific weight. Okay, good. So we just practiced specific gravity, density times density of the water, but the specific weight was something else. So the specific gravity one is really easy, just divide by density of the water. Specific weight was gamma, and gamma is rho g. Just multiply with g. So let's write down. This question is easy one. So question 5. Specific gravity was density of anything time divided by density of the water at 4 degree. So what was the density? 775 divided by, for example, 1000 to make everything easy for us. So it's going to be 0.75 and no unit. For specific weight, it's going to be rho g. Rho is 775 and g is 9.81, and it's going to be 7.6 times 10 power 3 Newton per. Okay. Yeah, question 6. This question still teaches you two important aspects. So question 6. A compressed air tank contains 5 kilograms of air at that temperature. A gauge on the tank reads that much pressure. Determine the volume. So it's talking about the gas, ideal gas. Do you remember ideal gas formula? Rho V on equal, but not V. Nu.
Yeah.
And what is the nu? Nu was the Yeah, reverse order density. What's the name? What?
It changes a little bit better.
Yeah. 286.9. This is for here. For other gases, it's different. And the unit is joule per kilogram. So, joule per kilogram. Yeah, 1 to 1. So this question wants to make sure you remember that one point about using ideal gas formula. All the values must be absolute, starting from 0. So the pressure is specifically says it's a gauge pressure. So you need to add atmospheric pressure, which is 101 kilopascal. And temperature says 80 degree, but it should be in Kelvin. So you need to add 273. So that's the only important point. So let me, this is question 6.
Is it off 8.81?
It's 286.9. These are, we need to read from tables. Nobody memorizes. So you remember the formula for ideal gas? We say PV equal RT, but not V, no. And we know that this is going to be 1 over density. So from this we can say that density is equal pressure divided by RT. This is P. If you saw I'm making mistakes, just let me know. Sometimes I say something but write the other thing. I don't know why. There's no good connection between my hand and my tongue. Okay. So pressure, we said it's 300. We need to add atmospheric pressure and times 10 power 3 to make kilopascal, divided by the air constant is 286.9 times T, which is 80 degree. Again, we need to make it absolute, 273. If you do the calculation, it's going to be 3.96 kilogram per meter cube. And the question says what? Find volume. So density is mass divided by volume. Therefore, volume is going to be mass divided by density. So mass was 5 kilogram. We just find density 3.96. So volume is going to be 1.26 meter cube. So don't forget this. Come on, I didn't do anything. Question 7. May I go to show a question, or you need time to write? Later I will share the answers, the solutions. Question 7. I just want to make sure you know the units. So for flowing water, what is the magnitude of the velocity gradient needed to produce a shear stress of 1 Newton per meter square? So you need to remember what is the formula for viscosity. Shear stress equal viscosity times velocity gradient. And let me give you the viscosity of the water. I can write here. Mu for the water is 1.12 times 10 power minus 3 . I will find a few tables for you guys. When you want to read the table, sometimes the numbers they are very small, like viscosity. They always have 10 power minus something. So tables usually do this. Let me go and show you here. This is, for example, our table. Different parameters. One of them is viscosity. And for the water, it says, what was the value? It will give you 1.12, but when you read the detail of that viscosity, it says multiplied by 10 power 3. So don't worry, even third year students, they make this mistake. When they read, they say, okay, I need to multiply viscosity that by 10 power 3, so 1.13 multiplied by 10 power. No, it says I already multiplied the value inside here by 10 power 3. So it must be 10 power minus 3 there. And we, as an engineer, we expect you to know the range of numbers. If it's 10 power 3, it's more viscous than honey, so it won't make sense. So it should be very small number, so don't make those type of mistakes. Sorry. So let's go back to the question. Again, this is a really easy question. What was the other name for this velocity gradient? du, dy. Anybody remembers? Another name. Shear strain. Shear stress is the stress. If you read the papers, like a scientific paper, they usually use shear strain. So everybody knows, okay, du over dy, or the magnitude of changing velocity over height. Okay, let me solve this question. This one was question 7. Question 7. So Let's write the formula for shear stress, mu du dy, and we're interested in this parameter. And remember, because there's the equality between shear stress and the part on the right side, so it's a Newtonian fluid because mu is constant number. Okay, so du dy is going to be shear stress divided by constant viscosity. It says shear stress is 1 Newton per meter square divided by the viscosity 1.12 times 10 power minus 3. So this is going to be 893 second, 1/2. I personally don't remember the units, but I remember the formulas. Whenever I need a unit, I just write the formula, put the units, and then find the. And for the viscosity, it's kind of, let me write unit here. It's usually everybody tend to forget. It is Newton second divided by meter square. But if you don't remember, just plug the units for this equation. Newton per meter square, meter per second, meter. If you simplify it, you can get easily the necessary. And this is the dynamic viscosity. Who remembers what was the kinematic viscosity?
Density.
Divided by density, because it happens a lot. So you're going to see a lot mu divided by rho all the time. We call it kinematic viscosity. Okay. Let's go question 9. We're doing good here. And I need to zoom out. Okay. So this question says a layer of water flows down an inclined fixed surface with velocity profile shown in the figure 9. So we have the velocity profile. But basic profile means what is the velocity over that height. So we have a formula over that velocity. Determine the magnitude and direction of shear stress that the water exerts on the fixed surface. For the U equal that and H equal that. Before you start, okay, give you a few seconds to write your notes, and then I want to talk about that formula, and then you can continue with the solving. Let me zoom over this formula. Okay, this is as a engineer, we tend to simplify everything. Remember, engineers, they are laziest people. Check out this formula. U, the small u is the velocity over different positions. And the maximum velocity is the capital U at the top. Y is the distance from the base. And you can see this. This is x direction, that is y direction. So y is another variable. And the maximum y is h. And in this formula, we came to divide u with the maximum u, divide y with maximum h. So this formula doesn't have any limit. So it's really easy to handle. And this is the tendency we have for every scientific work for the fluid mechanics and heat transfer. We tend to use to non-dimensionalize formulas because it's easy to work. For example, whenever you may ask what is the velocity in this pipe, I say 2 meters per second. It's not that much meaningful. Pipe is this small or 2 meters diameter. Totally different. For 2 meters, for big pipe is nothing. For 1 millimeter diameter pipe, 2 meters is huge. So it's two different, very different situations. So what we do, we convert that velocity to a dimensionless form, which we call it Reynolds number. Then nobody is going to ask, if I say Reynolds number in this pipe is 200, nobody is going to ask me extra question, because everybody knows, okay, when we say this dimensionless number, which is dimensionless form of the velocity, means for this type of pipe, and no extra question. It simplifies everything. So here, basically we simplified, no units. Okay, sorry, let's go back to our question. Question 9, okay. Determine the magnitude and direction of shear stress. Okay, shear stress, tau. You have the formula for shear stress, the formula for the viscosity. U formula is given there, so you need just differentiate over y. Did you write your note for the ideal gas? Always write absolute value. End of semester, when you're coming back, there is this is the, for example, for this session, you have 2-3 important points which I may use for the final exam questions. One of them is that. So make sure you know those important points. Write it in red. Or another important point was about the slope of that line for the density, for the viscosity. The slope is the viscosity. I may, instead of giving you the viscosity, draw a line, so push you to find the slope and then get that. Write in red. Okay, let me solve this question. Ready? Okay.
The slope of the line was the shear strength.
This was viscosity. Let me go back to show. So this is shear strain. This is shear stress line here, and the slope is going to be mu. So if I had another line with this slope, consider this a straight line, mu2 is bigger than mu1, more viscous than the other one because the slope is like this. Okay. Let's solve question 9. So we know the formula. Tau is equal to mu du dy. We have formula for u. Let me write formula. Is it a little bit hot here? Now breathe. Okay, so the formula for u is this: 2y divided by h minus y squared divided by h squared. So I need to find du dy. So I can simplify this like u equal the capital U times 2y h minus y square h square. So du dy is going to be u 2 divided by h. Basically the first one is just y. This is going to be 2y divided by h square. And if you read the question carefully, the question 9 says determine the magnitude on the fixed surface. Where is the fixed surface? At the bottom. So y equals 0. So I need to find du dy at y equals 0. So if I put y equals 0, it is going to be 2u divided by h. Okay, so let's find shear stress. So tau is going to be mu times the new value we just find here for du dy. Let me write like this: 2u capital U divided by h. Okay, mu for the water 1.12 times 10 power minus 3 times 2 u is 2 meter per second, h is 0.1 meter. So the final value is going to be 4.48 times 10 power minus 2 Newton per meter square. And it says tell us the direction of the stress, because water flows downward, so the force or the stress is going to be at the direction of the flow, so downward. If the question says what type of force or stress surface applies to the water, is going to be other, in opposite direction. So surface to the water is going to be in this direction, water to surface is going to be in this direction. Yeah. So let's show you the result there. And this is our final result. Next question is going to be question 10, and after that question 12, done. Okay, I'm going to show you the question. Come on. Oh, next page. Question 10. A 1 meter cube volume of water is contained in a rigid container. Estimate the change in the volume of the water when a piston applies a pressure of 35 megapascal. So this question is about compressibility, and The parameter for compressibility was bulk modulus. We had two formulas for bulk modulus. One in terms of volume, one in terms of density. Here volume is given, so go with volume. And this question says find change in volume, so delta V is the question mark. Bulk modulus is EV equal negative d rho divided dP divided by dV over V. The final value?
Oh, is it a constant?
dV is the question mark. We want to find dV. Let me write the formula, then everything is going to be.
No,
So,
EV is a constant for water.
oh yeah.
Oh,
Let me write the EV. EV is 2.15. I heard EV, not EV. 10 power 9 Newton per meter square. Usually we write like this: 2.15 gigapascal. Giga is 10 power 9. Oh. We give you tables to read. Let me check. Where is the table? See? Okay, slow. The last line.
So does that mean we time? Wait, no, that's just done.
If you want to write 2.15, up there you need to write 10 power minus 9. So we already want to Okay, I need to go back and finish those questions, also going to be important. Okay. So question 10 is also interesting. EV is equal negative pressure change. Oh, I can write delta P instead of TP. Pressure change delta P divided by volume change divided by volume. And that negative is because volume decreases. That is why we put that negative, because EV is always positive number. So delta V is going to be equal negative volume delta P divided by EV. If you plug the numbers, it is going to be negative. Volume is 135 times 10 power 6 divided by 2.15 times 10 power 9. So it is going to be negative 0.0163 meter cube, which means we have a reduction of the volume there. And let's go question 12 very fast. To do as many as we could. So this is about surface tension. What is the difference between the pressure inside the soap bubble and atmospheric pressure for a 3-inch diameter bubble? So remember, bubble was twice then droplets. Assume the surface tension of the soap film to be 70% of the water at that degree. You need to initial information. Let me give you surface tension. I selected this from another textbook, but I suppose I should have changed the units. But yeah, let's just consider the units are the SI units. Pound per feet. This is at 70 degree Fahrenheit for water. So the soap is going to be 70% of this, the surface tension. For the droplets, the formula was for the pressure change was 2 sigma divided by R. For the bubble, because we had 2 contacts with air inside and outside, it's 4 sigma divided by R. Okay, I'm writing. Sorry, I want to record as many as I can, so it will be useful for you guys. So question 12. So for the bubble, pressure change is going to be, delta P is going to be 4 surface tension divided by R, 4 times 70%, so 0.7 times the value I just gave you. The surface tension is going to be 4.97 times 10 power minus 3. This is for the bubble, divided by the radius. So it was 3, so 1.5 is going to radius divided by 12 to convert to feet. So this is going to be 0.111. This is pressure difference between inside and outside the soap bubble. Very small pressure difference. We just have 1 hour tutorial session, so we kind of in a rush always. So I'm going to cover this lack of tutorial session with videos. Already prepared some YouTube videos, so you're going to watch those. Because for next session, usually each question takes like 1 hour to solve if I give you all the details. So kind of going to compensate with some videos, and try to watch those videos, really important. So see you this afternoon. If you forget to sign, please sign the classes. Okay, let's finish the recording.